be upon you, my dear students in grade 11. We will continue our lesson, which is polynomial functions. Objectives. At the end of this video, students will be able to determine the extremum of a polynomial function, determine the elements of symmetry of the curve of a function. Materials. Before you start, prepare the following materials: textbook, pens, draft papers, copybook, calculator, and ruler. Now, we will start by the first objective in this video, which is the extremum of a function. Do you remember what is meant by extremum of a function? Correct. A maximum or minimum of a function is called an extremum. Let us revise the definitions of maximum and minimum. Let f be a function defined on an interval I, and let a belongs to I. F admits a maximum at a if there exists an interval j subset of I and a belongs to j such that f of x less than or equal f of a for every x belongs to the interval j. F admits a minimum at a if there exists an interval j subset I and a belongs to j such that f of a less than or equal f of x for every x belongs to j. Example: f is a function defined on -3, 3 where the adjacent curve is its representative curve. Determine the extremums of f. Look here, you will find a maximum point. What is the abscissa of this point? Correct, -1. So f admits a maximum at x equal -1. Again, look here, you will find a minimum point. What is the abscissa of this point? Correct, 1. So f admits a minimum at x equal to 1. Now we will consider a property in order to determine the extremum of a function in a way other than that of the definition. F admits an extremum at a point of abscissa a if and only if f prime of a equals to 0 and f prime changes its sign at a. Example: given the adjacent table of variations of f, determine the extremums of f. The first condition is f prime of a equals to 0. What are the values of x for which f prime of x equals to 0? Good. X equals 3/2 and x equals to 9. Let us see whether the second condition is verified. F prime changes its sign from positive to negative at 3/2. So f admits an extremum at 3/2. Wait, which extremum? Maximum or minimum? Look here, f is increasing, then it is decreasing. So f admits a maximum at x equals to 3/2. Also, f prime changes its sign from negative to positive at 9. So f admits an extremum at point of abscissa 9. Since f is decreasing, then it is increasing, thus f admits a minimum at x equals to 9. Application. Please stop the video, then solve this application. Application. Consider a function f defined on -infinity plus infinity by the following expression. Does f admit an extremum at the point of abscissa 0? Justify. Two students solved this application, Jad and Jawad. Let us see their solutions. Which of these students answered correctly? Please stop the video, then solve this application. Jawad solved this application correctly. Application. Please stop the video, then solve this application. F of 0 means the ordinate of the point on the curve of abscissa 0. This point on the curve has the abscissa 0 and ordinate -1. So f of 0 equals to -1. Similarly for the other ordinates. Part B. Please stop the video, then solve this part. The point on the curve of abscissa -2 is a maximum point, so f prime -2 equals to 0. The point on the curve of abscissa 0 is a minimum point, so f prime 0 equals to 0. Application. Please stop the video, then solve this application. F is strictly increasing, which means that f prime is positive. It increases till the maximum point of abscissa -1 and ordinate 4. Then f is strictly decreasing, which means that f prime is negative. It decreases till the minimum point of abscissa 1 and ordinate 0. Then f continues increasing, which means that f prime is positive. Thus, f is strictly increasing on -infinity -1 union 1 plus infinity. F is strictly decreasing on -1, 1. Before starting by the second objective in this video, we will give you a new definition. Let I be a subset of R and C be a real number. I is centered at C if for every real number x such that C plus x belongs to I, we have C minus x belongs to I. Let us calculate the midpoint of this segment. That is, C minus x plus C plus x over 2 equals to C. So C is the midpoint of the segment. Example. 1, 5 is centered at 3, since 1 plus 5 over 2 equals to 3. Similarly for the other example. Notice that the centered interval should be either closed or open. Application. Choose from the following intervals a centered interval at 2. Please stop the video, then solve this application. The correct answer is the closed interval -4, 8. Now we will start by the second objective of this video, which is the elements of symmetry of a curve of a function. The elements of symmetry means the axis of symmetry or the center of symmetry of a curve. Definition. The line of equation x equals to a is an axis of symmetry of the curve C of f defined on an interval I if I is centered at a, f of 2a minus x equals to f of x for every x belongs to I. Example. F is defined on I equals to 0, 6 by the following expression. Show that the line delta of equation x equals to 3 is an axis of symmetry of C. Here a equals to 3. Is 0, 6 centered at 3? Yes, 0, 6 is centered at 3, since 0 plus 6 over 2 equals to 3. The second condition is to prove that f of 2a minus x equals to f of x. Let us start by f of 2a minus x. If we substitute a by 3, we will get f of 6 minus x. Substitute x by 6 minus x to get this expression. Expand then reduce to get x squared minus 6x plus 5, which equals to f of x. The two conditions are satisfied. Thus, delta of equation x equals to 3 is an axis of symmetry of C. Application. Please stop the video, then solve this application. Let us see axes of symmetries of some curves. The line of equation x equals to -1 is an axis of symmetry of this curve. The symmetry of a point with respect to this line is also a point on this curve. That is, the line of equation x equals -1 is the perpendicular bisector of the segment joining a point on this curve by its image. Similarly for the other curves. As we said, the elements of symmetry of a curve means the axis of symmetry or the center of symmetry. We talked about the axis of symmetry. Now, what's about the center of symmetry? Definition. The point WAB is a center of symmetry of the curve C of f on an interval I if I is centered at A, which is the abscissa of the point, f of 2a minus x plus f of x equals to 2b for every x belongs to I. Example. F is defined on -infinity plus infinity by the following expression. Show that the point W02 is a center of symmetry of the curve C. Is -infinity plus infinity centered at the abscissa of W? Yes, -infinity plus infinity is centered at 0. The second condition is to prove that f of 2a minus x plus f of x equals to 2b. Let us start by f of 2a minus x plus f of x. That is, substitute a by its value, which is 0, to get f of minus x plus f of x. Substitute x by minus x and write the expression of f of x. Reduce this expression to get 4, which equals to 2b. Don't forget that b equals to 2. The two conditions are satisfied. Thus, W is a center of symmetry of C. Application. Please stop the video, then solve this application. Let us see center of symmetries of some curves. I is the center of symmetry of this curve. The symmetry of a point on the curve with respect to I is also a point on this curve. That is, I is the midpoint of the segment joining a point on the curve by its image. Similarly for the other curves.